Alright, this is a video for homework 5, and that's gonna be uh, 8 cantilever using 8 different type of elements. Okay, so this is the results you're gonna get, and let's start making the fan and the seam. So first step we need for this homework we need a CAD model. So let's build a new model file. Let's say homework 5 PRT. Okay, and we're gonna have 8 cantilevers, and so we can come here and use insert design feature, and we can insert blocks, and the size the length of the beam is 30 inch, the width is 3 inch, height 2 inch. Okay, and first we're gonna specify uh, the origin for this bricks. So for the first beam, it's gonna be at the coordinate system origin, and we can click OK, and now we can click Apply. That's our first beam. Okay, so we want 8 beams, and the interval between two beams, that's gonna be 5 inch. So next we're gonna specify the origin for next beam. Let's click this, and that's gonna be 8 inch apart from the orange, and it's gonna be on Y direction. So the next point is gonna be 8 at Y, and then click OK. Here we click Apply again. Now we get the second beam. So we can keep insert the beams at next spot. It's gonna be Y at 16. Okay, and apply. Then next point is Y equals I think 24. Okay, apply. Now we have 4 beams. Let's keep doing this. 32. Apply. Then it's gonna be 40. Apply. 48. Apply. And the next one is 8, 16, 24, 32. Apply. 1, 2, 3, 4, 5, 6. Okay, we missed the one at 40. 40, and click apply. And the last one, 1, 2, 3, 4, 5, 6, 7. The last one is gonna be 8, 8, 56. Okay. Now we can click OK. So now we have 8 beams. Okay, we are done in the CAD part. So now we can come here, click Start, and Advanced Simulation. Okay. Now you right click on the part and choose New Fan and Simulation. So just click OK. And here we just use default. Click OK. Now we are in the sim, and we need to mesh these beams in the fan. You can double click here at the fan file. Now you can see here we are in the fan part, and okay, we have 8 different type of elements. So first we're gonna use 1D element. Okay, so we can come here and drop down the manual. That's your 1D mesh. Okay, and so we need to select the object, and here we select the edge of this box. Okay, and the number of elements you want to change it to 10, so we can have 10 elements along the length of this beam. We can click apply. Okay, and nothing happened, but if you look at the navigator, we can see there's a 1D mesh here. Okay, so we can turn on the display of nodes. We can come here at preference model display, then change the mark type to star. Okay, so that's your 1D element. Next, we can define the cross section of this 1D element, as well as the material. Okay, and we're gonna right click on the collectors and click the monkey wrench. Okay, and here also make sure the element type for 1D element is C bar. Okay, now right click the collector and edit, then the wrench again. So here we can use the section manager and build a new section. Click this button. We're gonna choose bar, and the dimension. Okay, dimension 1 is for thickness, I think, and dimension 2 is the height. We can preview. Just click OK and close this. Now next step is the material, and if you click this button, okay, and choose the library materials, it's gonna be steel. Yeah, then we're done here, and you can see the cross section is defined, so we can see the bricks. And don't worry about the offset from your CAD model, it doesn't matter. Okay. Alright, for next beam is gonna be a 2D mesh, and we are going to use the triangles. We have linear triangle and parabolic triangles, as well as quad. We also gonna use quad elements like linear quad and parabolic quad. So we have 4 2D mesh, and let's start with 2D mapped mesh. So for 2D mesh, we're gonna use this method. 2D mesh, okay. And first we're gonna choose the element type. So for the first beam, we're gonna use C triangle 3. So that's your linear triangles. Okay, and you can select the object. It's gonna be a face. So we want to select this face, and the element size is gonna be 3 inch. Okay, now we can click apply. Now you can see there are 20 triangles here. Okay, alright, so we can proceed to the next beam, it's gonna be parabolic triangles. So the element type is triangle 6. The element size is the same, 3 inch. We can pick the next beam, the surface, and click apply. So now, even though the shape of these triangles, they are the same, but you can see the different numbers of nodes within one triangle. Alright, for next beam it's gonna be quad. Okay, so quad 4 is your linear quad element, same size, and pick this surface and click apply. So we got 10 boxes. The next one is going to be parabolic quad. That's quad 8 element, and the element size is going to be 3 inch. And let's pick this surface, apply. Again, you can tell from the number of nodes within one element. That's your linear. This is parabolic. Okay, so far we're done with the 2D elements. We have 4 different type of 2D elements, and you can see from here. And we're gonna define the thickness of these 2D elements. Okay, so the thickness is gonna be 2 inches. And we can right click on the. We can right click. Okay. Yeah, right click on the thin shell. Excuse me. Then we can click edit. And let me try this. Yeah. Okay, then let's do it one by one. Right click on the thin shell and click the monkey wrench, and the monkey wrench again. Here we're gonna type in the default thickness. It's gonna be 2 inch, and the material we can select it steel. So once you picked a material in previous operation, it's gonna be in this menu. Okay, so 2 inch steel. Click OK, then OK, and let's do the same for the other 3 beams. Steel, 2 inch. Okay, same here. Steel, 2 inch. There's also a way you can put all this mesh in one collector. So that way you just only needed to define once. But here we just keep doing this. Alright, we have 3 being left. That's gonna be 3D elements. So for the first beam, it's gonna be rectangular bricks. Okay, so we can come here and use 3D swept mesh. Okay, so for this beam, we're gonna select the source face. The source face is gonna be a tip of the beam. Okay, so the mesh is gonna use this shape and sweep along the length. The element type here is gonna be C-hex 8. That's our rectangular bricks, and the element size is gonna be 3 inch. So that means every 3 inch there will be a cross section. Okay, let's have a look. Just click apply. Then you have your 3D swept mesh. Okay, and for next 2 beams we're gonna use free mesh. So we're gonna use 3D texture mesh, and the first one is linear texture, so that will be texture 4. So you can tell from this icon you have 4 points in one element, and the element size is 2. So for this, it's different from the other beans. Okay, so this is size 2, and then let's pick the geometry. This one. Click OK. Alright, now you can see this is a free mesh and a 3D texture. So for next element, we're gonna use parabolic texture, and keep the element size 2 inch. Let's select the last bean, and then we can click OK. And as usual, they have the same shape, but the number of nodes in each element is different. So here is parabolic, that's linear. Okay. Alright, so we also need to define the material for 3D mesh. Again, we're gonna right click on this solid collector and edit, then edit again. Okay, material, you can select from the menu, that's steel, and the second one, edit, steel, click OK. Okay, the third one is also steel. Alright, so here we have the 8 mesh, and we can turn off your geometry here, polygon geometry. Okay, so we have done everything in the fan. We can go to the scene part. Okay, let's go to scene, and now we're gonna apply loads. Okay, so the load is gonna be on negative y direction, 300 pounds. So let's input the load. So here we can put the load on 1D element. We can put the load on this node. On 2D, we don't necessarily put the load on 2 nodes. We just put on the top node. Okay. So for 1D and 2D, the load's gonna go on one node for each beam. Okay. And for 3D elements, we're gonna apply loads on the 2 corners. So for 300-pound load, we're gonna apply 2 150 pounds on each node. Here, and here. Alright, now let's apply load. That's gonna be the force. And here we can select all this 1, 2, 3, 4, 5 nodes. We can select these 5 nodes at once. Okay, and I want wireframe. It's easier to see. So 1 node, 2 node, 3, 4, 5. Okay, so we have 5 nodes, and each node has 300 pounds. So the total force is gonna be 1500. Okay, so because this nx will divide the load into four nodes, or 5 nodes. Sorry, and the direction is gonna be y negative. Okay, so 1, 2, 3, 4, 5 nodes. 1500 y negative, and we can click apply. Okay, and you can look at the this loads here. Alright, for the 3D, we're gonna have 150 pounds on each node and 2 nodes for each beam. So let's pick the nodes. Can pick this 2 node and that 2 nodes. Okay. For this one, we also just apply it at the corner nodes. Okay. So now we have 6 nodes and 150 each. So that's gonna be 900, right? 900 pounds on Y. The vector is gonna be Y negative, and we can click OK. Alright, so we have the load here on all the beams. Next step is gonna be the constraint. Okay, so constraints, we need a fixed constraint. Okay, and here we can just box select the nodes on the leftmost side. Okay, and make sure we select the right nodes. Okay, and here. Alright, for this we're gonna zoom in a little bit and select all these nodes. Just make sure. Okay, when you select OK, and we can see those tiny little full constraint icons. You can also edit display and make them really big. Okay. And let's check the constraints again. Make sure you only select the nodes at the left side. Okay. Alright, so we have elements, load, and the constraints. Now we can, let's save all first. Save all. Okay, and we can do a model check, model setup check. It looks all good. If you forget to define the material, you will see a lot error and warning here. Alright, now we can run the simulation. Just right click on the solution and choose solve. Click OK. Alright, finish. And let's have a look at the results. Okay, double click the results and double click the displacement. Okay, go for F8. So we can also identify the deflection on each node. You can see this is the maximum deflection, and where's that node? Okay, that's also matches this maximum deflection. But here, if you look at the linear triangles, try to snap on this point. Do that again. The deflection on linear triangle is very small, as well as this one. So we have two beams has some awkward deflection. You can also invest this point. This is only about half of the deflection of the other beams. And if you remember, this is your linear texture. So we have linear triangle and linear texture that's very stiff, and that is because this element, okay, this element only has 3 points at each triangles, and that's a very stiff element. So the linear triangle and the linear texture will have pretty bad results on this kind of simulation. They have other uses, but for this structural problem, they're not good element to use. So this homework gonna demonstrate the effect of different elements. And after you done the simulation, you can get this deflection and compare to your hand calculation, and give us the percentage error of your deflection. Alright, so here we go. Thank you very much.